Welcome to part 2. It's the third problem. The water tank has the shape of an inverted circular cone with a base radius of 2 meters, so this is 2 meters here, and a height of 4 meters. The water is being pumped into the tank at a rate, so we know it's being pumped in, so that's dV over dt at a rate of 2. Find the rate at which the water level is rising, so we're looking for dH over dt when the height is 3. Now, whenever you see a cone, not whenever, most of the time when you see a cone, the one thing that you're going to have to know is the fact that you're going to have to look at similar triangles, because what happens if this was 3 right here? Change color so I don't mess it up. If this right here height was 3, we need to find that R value. And the only way to do that is to recognize that this right here, that triangle, and this triangle are similar triangles. You notice that they share the same angles, and therefore they're similar triangles. And so when we have similar triangles, you can set up a proportion. You know that the proportion of height over radius is equal of one triangle is equal to the proportion of the second triangle. So that's kind of for the side business here. So we'll go back to the original, and we are looking for the rate at which the water level is rising, knowing volume. So we're going to say the volume of a cone. You want to remember that? 1/3 pi r squared h. Now, here's the thing. Notice how many variables we have. We have volume, we have radius, and we have height. That's where this comes into play. Because I can't have I shouldn't say I can't. I can have 2 separate variables. It just is going to make life very difficult, because if I take dV over dt here, I now need to use product rule. Can you believe it? R squared times h. So 2r h dr over dt plus r squared dh over dt. Now I have to find 3 different rates. That's not what we're given here. So this, as long as you can do it, great. If you have all rates, great. And there will be problems where you can do it like this. But let's go back here and let's try to solve this. If I know that the height and radiuses are proportion here, we can actually substitute in, because I know, go change to a different color here for it. I know that my radius and my height, 4 over 2, is always going to equal h over r. So I'm going to get 4r equals 2h, and I need it in terms of what we're looking for. We're looking for h, so I need to make sure that I'm substituting in for r. So I can say that r equals h over 2 if I divide by 4. This can now go in for r. So I can rewrite this. Volume equals 1/3 pi h over 2 squared h. The reason I'm doing this is now look at how many variables I've got. I now only have volume in terms of h. That's a good thing. I'm looking for dH over dt. I don't have to worry about r. I don't have to worry about product rule. I don't have to worry about finding 3 different rates. How did I get this? H squared is h squared times h is h cubed. 2 squared is 4. So I can now say that this 1 times 4, so 1/12 pi h cubed. Now I can take the derivative, substitute in for when h equals 3. When h equals 3, if I want to look over here, I can say 4 over 2 equals h 3 over r, and substitute 4r equals 6, r equals 6 over 4, which is 3 over 2. Now I know what r is when h equals 3, and I can substitute in after I take the derivative. So Notice I always said I go over in the side and find something out. So I'm going to take the derivative. dv over dt equals 1/12 pi, that does not change, times the derivative of h cubed, 3h squared dh over dt. What do I get now? 3 and the 12, 1 over 4 pi h squared dh dt. And now I can solve when h equals t, or when h equals 3, excuse me. Nope, no implies there. Plug in. So 1/4 pi h is 3 squared dh over dt, that's when h equals 3, that's why we have to plug that in. dv over dt, you look at the back of the front of the paper, is 2. So now I can say that's 9/4 pi, and the pi, notice, is really in the numerator, dh dt, when h equals 3, equals 2. And so when I need to get this over, it's really 9 pi over 4. If I multiply by the reciprocal, the 4 goes with the 2, 8 over 9 pi equals dh over dt when h equals 3. And so we just solved it. We know the rate at which the height is changing when the height is 3, which is 8 over 9 pi feet per second. And so you would write that out. And I misspoke. The water level is rising at a rate of 8 over 9 pi meters per minute when the water is 3 meters high. And that's what I would expect to be written out. So just as a recap, when you are given a cone, you might need to realize that there are similar triangles. We wrote down the volume equation of a cone. We usually write cone here. Should have imply symbols all the way throughout here. We found it in terms of 2 variables, not 3, but 2. We then solved for what the radius would be when the height is 3, plugged in, and we got our rate at the rate that the water level is rising. So again, the idea is take the derivative of the equation you're given, then find the actual dimensions, in this case height and radius, for the specific time, and then plug in and solve. The very last question, this is always a fun one. A man walks a straight path. Let me draw this out and you read it and you can draw it out and then we'll compare. So we've got a man walking on a path, we've got the spotlight. Now, what people don't understand here is when this rotates, this is what we're given. We know that the rate at which the searchlight is rotating when the man is 15. When it's rotating, it's actually shining here, and then when the guy is this far down, it's shining there. What is that rotating? It's an angle. This is an angle. And yes, we can even do related rates with trigonometry. And so, what did we create here? Well, if the guy's 15 feet down, here's 0 feet, and the guy's 15 feet down, this is 15, right? And we're shining this way, what have we just created? A triangle, where this is theta. And so we're looking at trig here. And so we're going to have to take a derivative of trig functions and find the rate at which this light is rotating so it stays on the man. So I'm going to draw another triangle just so we have it here. And we know this is 20 and we know this is theta. And let's talk about givens. I'm just going to label this A, B, C, just so we have it. And we know that dB over dt equals 4. We also are looking for d theta over dt when B equals 15. So we need to know how are A B and theta all related. Well, we have right triangle trig if we're trying to figure out how they're all related. We have the opposite, we have adjacent, we have the hypotenuse here. And so we can, if we're looking at A, B, and theta, A and B are opposite and adjacent, we know that that's tan theta equals opposite over adjacent. And now we can try to plug in. Tan theta equals opposite B over 20. And I can solve for B, so at least B is on its own, 20 tan theta equals B. And I'm kind of stuck here, there's really nothing else to do, so I'm going to take the derivative of it. 20 secant squared theta equal, let's not do what I would expect you guys to do. Let me not mess that up. When I take the derivative of tan theta, it's tan theta, the derivative of tan is secant squared, keep the inside the same, times the derivative of the inside. Cannot forget that. Equals dB over dt. Now, notice that I know what dB over dt is. So I can say that 20 secant squared theta d theta over dt equals 4. Notice that even if I want to find d theta over dt when b is 15, I need to figure out what theta is. So that's where I come to my side. So I'm going to draw the same triangle. Okay, 20, but this is when b equals 15. So that's okay, because I'm going to plug in. Using Pythagorean theorem, you can do it out, but that's using Pythagorean theorem. That's 25. So this is still theta. Okay. What we need to do is secant. We got to look at what we're looking for. Well, secant is really cosine. So what I need to find is cosine theta. We know cosine theta is A over H. So in this case, cosine theta equals A 20 over 25. So cosine theta equals 4 over 5. So that's when b equals 15. Just remember, we're finding this thing, d theta over dt when b equals 15. I could rewrite that, if I wanted to, times 1 over cosine squared theta, d theta over dt, equal 4. Notice I know what cosine theta is when b equals 15. So I could state here, if I know what that is, that's really 4 over 5 squared. D theta over dt, because I plugged in, that's when b equals 15. And because I plugged that in, I can now solve that. It's really saying 20 times 25 over 16, excuse me. And now the simplification goes. So you guys can simplify. And so you should have gotten, when you simplified it out, to be 16 over 125, 16 divided by 125 radians. And notice how I wrote it out. We're in trig, and so therefore we must be in radians. Calculus is almost always done in radians unless specified. So it's rotating at a rate of 16 over 125 radians per second. So that is related rates. Again, it's the same idea. We found the derivative. We then use the information given to find the specific dimensions, or in this case, the specific ratio, to find the answer. And to end it off, the joke time. Probably have heard this, but why are math books so depressing? Because they are full of problems. See you in class.